Let's do some guided practice for the last part of 4.1, the formal definition of the derivative. Here we're going to find the derivative of the function f of x, not at a specific value, but just for the general variable x. But of course, the actual differentiation is the same process as before. We just plug in x plus h instead of a plus h. So this is going to be 3x plus h, quantity squared, minus x plus h plus 1, right? That's our f of x plus h. And then we're going to do minus our f of x, which means just rewriting the function. And again, please make sure to put it in parentheses so that the minus sign gets distributed properly. Right, now this just requires a little bit of simplification, right? We have to square the x squared plus h, or sorry, the x plus h quantity squared, but this will just wind up being 6xh plus h squared, right? Because the middle term, just to be clear, I got this from this. Oh, and I have a little mistake. Oh, it should be 3h squared, right? Okay, anyway. And then this is going to be minus x minus h. Be careful about that minus sign. Remember, see how the minus sign distributes? And then plus 1, and then minus 3x squared plus x minus 1, right? Because the negative sign distributes to each of these terms, right? So it's opposite day up there. And then anyway, we just, kind of just do that all over h. And then we have some cancellation, right? We have 3x squared minus 3x squared minus x plus 1 minus 1. The way it always works. Remember, all non-h terms should cancel out. Anyway, we keep writing this out. We get the limit as h approaches 0. And I'm going to factor out an h from these remaining terms. We have 6x plus 3h minus h. You could simplify that if you want. But I'm going to... Oh, sorry, that's actually a minus 1. I lied. I guess you can simplify that, right? We factored out an h from each of these terms, right? And then we have that h on the bottom. Remember, the goal of all of these limits is to cancel out that h on the bottom so that we're not dividing by 0. And we just wind up with 6x minus 1. And sure enough, that's our answer. Okay? Remember, our answer is a function, not a number. That's the case with polynomials, right? Factor out the h. Simplify, factor out the h. For square roots, same sort of thing, except first we have to multiply by the conjugate over the conjugate, and we get this. Right? F of x plus h minus f of x all over h. All right, so if you're familiar with multiplying by the conjugate over the conjugate, then you know we're going to be multiplying by this. Right? Note that that's all inside the radical. And then over, let's be lazy and just kind of duplicate this bad boy. Yeah. Awesome. All right, and then remember how that's going to go. All right, we're going to get limit as h approaches 0 of x plus h plus 4 minus x plus 4, right? The radicals go away. Make sure that the x plus 4 is in parentheses because that minus sign will need to distribute. And then the bottom is, this lovely thing. I'm just going to be a little bit lazy once again and duplicate, right? I'm just going to stick that down there. Just stick it down there and just don't even simplify. Right? And then, of course, we notice that some stuff is going to cancel. The x's cancel, the 4's cancel, and we are left with the limit as h approaches 0 of h all over h times, well, you know, it's going to be our duplicate, right? Times this nonsense, right? Maybe I could shrink that a little bit. Maybe that's a nicer thing to do, right? Just shrink it. And anyway, when we shrink it, we notice that the h's are going to cancel out. We just have a 1 up here. And so we're left with the limit. Oh, sorry, actually, I'm not even going to write the limit. We can just take the limit at this point. We're going to get 1 over the square root of x plus 0 plus 4 plus root x plus 4, which is 1 over 2 root x plus 4. And that's our answer. Last but not least, we have the derivative of a fraction. And remember with fractions, we have to do a common denominator. That's the trick for this guy, right? So we have 3 over x plus h plus 1 minus 3 over x plus 1. And then this is all over h. Now remember, this is kind of yucky. I don't like repeated fractions. Let me put this over here. So what we do is we talk about the limit as h approaches 0 of, and we just take the 1 over h and we put it out here. And this is just so much nicer than what we had before. Whoop, I think I'm missing half of that x right there. X plus 1, right? Much nicer, right? Now we don't have repeated fractions anymore. But we still need to cancel out this h on the bottom. Remember, that's always the goal for these limit problems. So how do we do this? Common denominator. We're going to multiply this guy by x plus 1 over x plus 1. We're going to multiply this guy by x plus h plus 1 over x plus h plus 1. Yeah, not the nicest denominator. But remember, once you do this, once you get the common denominator, the trick is that you can just write it as one big fraction. So one big fraction will be x plus h plus 1 on the bottom, x plus 1 also on the bottom, and then we just have this on the top. Minus 3x plus h plus 1. In case you're wondering what those brackets are, they're just parentheses. Just helps you distinguish, right? You see where I got this from? Oop, no, let's do, right, this guy. I got this here, this there, and then, of course, this just came from, well, both of these because they're common denominator. Right, and now we're just going to continue this. This is going to equal the limit as h approaches 0 of, and we're just gonna simplify that top, right? We're gonna get 1 over h, that's an h, promise, times 3x plus 3 minus 3x minus 3h minus 3. Right? Note that I just distributed the stuff in the top, and just to be clear, this stuff is here. That stuff is there. Okay. And then we're going to get this lovely stuff on the bottom here. Times x plus 1. And then let the cancellation begin. Remember, all the non-h terms should cancel on the top, and we're left with a negative 3h. You see that? And now at this point, let me see if I can skip this. Let's see if you see this. We can cancel out that h and that h. Do you see that? And then we're left with the limit as h approaches 0 of negative 3. Don't forget that negative sign. Over x plus h plus 1. Oops, that's going to be a bracket. Times x plus 1. And then we just evaluate this at h equals 0. And, of course, the h just goes away because it becomes 0. And we just have 3 over x plus 1 times x plus 1, or negative 3 over x plus 1 quantity squared. And that's our answer.